Welcome back, and here we are, episode 10 in the Try Hack Me Old Man Hacks the World series. Today, in this episode, secure network architecture, we're going to learn about and implement security best practices for network architecture. Let's get it on. First things first, join the room. Okay. So, today's learning objectives: 1. Understand the principles of secure network architecture design. 2. Learn and implement common network security concepts and protocols. Number 3. Understand a network's environment and potential threats. Alright. If you've just found this video in your browsing or it was recommended on you, thanks for clicking on it. I hope you like it. I hope you click the like button and hope you comment below and tell me why you liked it, or maybe you hate this. Maybe this is the worst video on network security ever. Hit the dislike button and write me why you didn't like it. Because otherwise, how am I going to learn? I just be here making videos. These videos are great. But in reality, they suck. And if that's what you think, let me know. I need feedback, people. Just don't watch and move on. Engage. Life is so much better that way. It's a two-way street we're on. Okay. So that completes our little intro part. Yeah, I got it right. Network segmentation. Okay, so essentially this is where your subnets come into play. No, it's not. Oh. Okay. It says subnets seem to solve all problems a network may face. And why would you use something else? And then it explains why. Let's consider a scenario where your work has a bring your own device policy or practice. And I guess really the only reason I would allow a company that I was running or had a say into, bring your own device is if, we're startup, and we don't have a whole lot of funding for hardware. And so, say, hey, yeah, just bring your own laptop, whatever you want, and whatnot. So, anyways, so this happens. A client brings in their own device. The client's device was infected with a remote access Trojan, a rat. Dun dun dun. And it's going to attempt to traverse the network the device is connected to and exfiltrate any sensitive information. And with subnetting in place, there's no restriction in place to where the infected device could connect as long as the proper routes are in place. So, it'll go from one subnet to another. You just route it to that subnet, and boom, you're there. So, solution is VLANs, or virtual LANs. They're used to segment portions of a network at layer 2 and differentiate device. So how they do that is they're configured on a switch and it adds a tag to a frame. The 802.1q or .1q tag will designate the VLAN that the traffic is coming for and is intended to. Okay. So here's a few commands. In this example, they're using the open source switch, Open vSwitch, to look at the default configuration, OVS-VSCTL space show. And then you need to modify the settings to add a VLAN. So to do that, you can go OVS VSCTL space set space port space interface space tag equals 0 through 99. So you can have up to 100 VLANs 0 to 99. It tells you how to tag unknown traffic. It uses the native VLAN. All right. All right. Very cool. Some more stuff here. Let's get right into it. Y'all can read. You can do it. Hit that like button if you like it. All right. So here's the output of a various switch. Bridge BR2, NetDev, internal. Then we got all the different ports assigned to the various different VLANs. It's kind of cool. How many trunks are present in this configuration? Well, what did it call a trunk? Does not say, but I am going to assume that these are the different trunks, the bridges. 1, 2, 3. Ow! Gosh, you're such an idiot, Tony. Your answer is incorrect. Let's get a hint. ViOS uses bridges as trunks. Oh wait, there's one down here. Dang it, I missed that one. So that's 1, 2, 3, 4. I was right. I just didn't count because yeah, old man stuff. Yes, there we go. What is the VLAN tag ID for interface ETH12? Ethernet 12 tag 30. So VLAN 30. Whoop whoop. That's how you do this. All right. Let's move on to common secure network architecture. So I mean, we got VLANs, So what? What's the big idea? Well, we can use VLANs to create security zones. Example: the external zone is everything outside of your network or asset control. So the world at large. And then we have the demilitarized zone. So this separates the untrusted network, the external zone, from internal trusted zones. So this is where you connect the BYOD. You'll have your guest Wi-Fi's and your to a certain extent some of your web serving devices will be in the DMZ. And then I would say the rest of these are all internal, of course. You have your trusted, which is internal networks devices, and they're only in this zone if they don't have any confidential or sensitive information. And then your restricted zone are any high-risk servers or databases. For example, your HR databases that contain PPI, your financial databases that have your financials of your business on them, and then management. Those are devices, services dedicated to network device management. So your firewalls, your network devices, anything that like your IT admin would control, that would like be their sole use, would be in there. And then your audit is any devices or services dedicated to security or monitoring. And sometimes that's grouped with management. Okay. Oh look, a cool little picture. Yeah. So from the above table, dun, 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 what zone would a user connecting to a public web server be in? I'm going to say that's external because you're outside. Survey says yes. Oh, got that right. Way to go. Okay. Whew. From the above table, what zone would a public web server be in? And that's your DMZ. Because it's going to be, it's kind of like, what's a good analogy? I don't know. But essentially, it's going to stop external traffic there while allowing resources. It's like the gopher, the go person that they go in between. Anyways, I'm rambling. Shh. Okay. Yes. Moving on. From the above table, what zone would a core domain controller be placed in? I'm gonna go with the management because it kind of manages things. Survey says, oh no, it's incorrect. Oh, it says right here, restricted domain controllers. Sometimes it helps if you read the text. Just sometimes. Restricted. I find it interesting that they have the same number of letters. It's just me. It's my OCD. All right. Task 4, network policies and controls. So we got it all set up now. We got our zones. We got our VLANs. We're doing good. But are we done? No, not yet. Okay. Because what good are rules if you don't enforce them? I know that's not a popular opinion in today's society. However, rules are meant to be followed and enforced. Otherwise, you get chaos. Okay, so we got traffic filtering using an access control list. And then, we can, on VOS, we create ACL and define the policy, set policy access list ACL number. And we can also set the description. We can create a new rule under the ACL and define the action of the rule. So essentially everything happens through the terminal. You just gotta know how to do it. Okay. So we have ACL and ACE. And see what this is doing. Okay. 'Cause this is a valid SSH request permitted by the ACL. And this is an invalid SSH request denied by the ACL. So, once you got all your rules and your stuff set up, your firewall and your switches, wherever you got your rules, usually it's the firewalls because that's how it's done. But it's going to examine the packets as it comes in, and if it follows the rules, it's going to let the packet go forward into the network, into the destination. If it doesn't follow the rules, it's just simply going to drop it, probably log it, and that's cool. All right, so let's look at some of these packets. All right, Internet Protocol version 4, source is 10.10.212.209, destination is 10.10.212.209. So the source and the destination are the same. Interesting. All right. Yeah, I did read that right. Cool. You gotta go down to the next level, Tony. Destination source port is 35560, and the destination port is 22. Sequence is 1578. Acknowledgement is 1670. Length is 148. Source port, destination port. All right. So, first things first. Set policy access list 1, rule 1, action permit, and then you update that rule, the source, and this is the loopback IP, and then also that port. Okay, here's the second one, and you deny it. Okay. According to the corresponding ACL policy, will the first packet result in a drop or an accept? Well, it's permitted, so I'm going to say accept. That, and I can tell because of the length of dashes. They should hide those. Survey says yes. All right, and according to the corresponding ACL policy, will the second packet result in a drop or accept? Since we're saying deny, it's going to be dropped. Yay! Moving on. So some things to consider. Is the size, the traffic, and data correlation. And then also the protocols and requirements of a zone. And so yeah, we got to deploy firewalls. So yeah, we've gone over firewalls. In a previous video, I'll promise to put the link, the card thingy. You can do it. It'll be there. All right. Then we can also we can define different actions based on the protocol and the source destination zone. So we can have zone pairs. They're direction-based and stateful policy. They'll enforce traffic in single directions per each VLAN. hence zone pair. For example, DMZ to LAN or LAN to DMZ. Because sometimes, you want your rules different for things coming in versus things going out. Generally speaking, things going out are more secure because they're going from a secure environment to a lesser secure environment. But we also need to make sure that we're not spilling data out from a very sensitive zone to the external zone. So, okay, let's get her done. Okay. So, what we're going to do, we're going to configure a firewall. So, the syntax is interface dot VLAN number example eth0.30. Set zone policy zone DMZ default dash action drop. Set zone policy zone DMZ interface eth0.30. And you got to do that for each VLAN interface. See, this right here is why NetOps and NetDevOps is becoming such huge. I mean, imagine setting up a brand new network, an enterprise level network for like a network with a 1,000 workstations or whatever, enterprise level stuff. I mean, you literally be there all day, trying to set this up, type everything out. And so things that automate are in such huge demand right now. Okay. So we got a little bit of topology chart. We got LAN to WAN, ICMP, actions drop, LAN to local, no actions. Okay. Cool. So, yeah, we can use this to configure the firewall. Remember, children, not all traffic is IPv4. You may also need to implement IPv4 or 6 rules. Sorry. Okay. So, particularly if you're dealing with Internet of Things devices on your network, you'll definitely have IPv6, and depending on how many IPv4 addresses you have or don't have, it just may depend. So you may have to duplicate the same rules twice, once for IPv4 and a second time for IPv6. So it looks like we can use some brackets. Is that brackets or braces? The squiggly things to combine the rules and whatnot. Okay. Very interesting. So the zone pair is now defined with appropriate actions and states using all that. Oh wait, was I supposed to start a machine? Oh, click the button. Gee, I wonder why it's not working. Okay. DMC default action drop. So DMC interface 30. And so we got, that's this right here, I think. Zone DMZ, default action drop, set policy zone Lillian. No, this is, I don't know where this data's come from. Is it here? It must be here. I don't. I hate when they have like freaking. Oh, so we gotta do this. That's okay. Let's do the right data. Okay. So now we have understanding the basic zone pair policy. Launch the static site. Okay. And we're going to do this chart. Alright, so set policy zone DMZ. Default action is going to be drop. Set policy zone LAN. Interface. No, this is DMZ. Interface is 010. Alright, set policy zone LAN. Default action is drop. Set policy zone LAN. Interface 020. So then we got DMZ to LAN. Description. HTTPO. DMZ. Set firewall name. DMZ LAN. Default action is accept. And then let's do DMZ to WAN. Rule 100 action is accept, drop. Set firewall name. WAN, DMZ to WAN. It has no protocol, so we'll do DMZ. Okay. DMZ. Drop. DMZ interface 010. Then we got LAN default action drop. LAN interface 020 firewall name. We're going DMZ to LAN. Description DMZ to LAN. Firewall name DMZ to 1. Default action is drop. Firewall name LAN to DMZ. Rule 100 action is drop. And then WAN to DMZ. Rule 100 protocol is screw it, I'm just going to go ICMP. Okay. DMZ to the LAN. Alright. DMZ to accept. I don't know. No, it does say accept. Let's do DMZ. DMZ. And it's going to be HTTP. Yes! We have a flag. Yeah. M 05 TLY 53 cure. Oh, let's put an underscore in there, eh? Thank you. I don't know if this old man could have taken that again. I mean, why start your network if you don't have it set up? I don't know. I just don't know. Okay. So, let's validate some network traffic, eh? To begin this test, let's start with the scenario. Your organization has proper zoning and routes in place as zone pairs and allows for HTTPS connection. Of course, it's got a firewall that accepts those connections. And then how else is Susie administrator supposed to watch Facebook or your Azure updates installed? Well, if there's a threat actor that has landed an implant through phishing on a LAN machine, we're in trouble. What we need to know is how can the implant be detected and monitored? If their beacon is using HTTPS traffic through the DMZ, it's going to look like primarily legitimate traffic to your firewall and analysts. To solve this problem, we're going to use SSL/TLS inspection to intercept those connections. Okay. So, SSL/TLS inspection uses a SSL proxy to intercept protocols, including HTTP, POP3, SMTP, and other SSL/TLS encrypted traffic. Once intercepted, the proxy will decrypt the traffic and send it to be processed by a UTM, a Unified Threat Management Platform. Okay, so that seems pretty straightforward. So the downside is it requires a proxy or a man in the middle, which answers our first question: does it require a man in the middle proxy? Not to be confused with a man in the middle attack. That's something different. The answer is yes. At least that's what they said. I'm going to be mad if they lied. They did lie, yes. And then the platform is a UTM or Unified Threat Management Platform. Yes. Okay. Amazing. Let's move on to addressing, and this is the last thing, the absolute last thing we're going over in this video. Thanks for sticking with me. Hope you guys are finding this interesting. So we got some attacks here we're going to learn about. First is DHCP snooping. Cisco defines DHCP snooping as a security feature that acts like a firewall between untrusted hosts and trusted DHCP servers. Oh. Interesting. It detects rogue DHCP servers. So if a threat actor sets up a fake DHCP server, and this can figure it out and it'll block it and stuff. Pretty cool. Then we got ARP inspection. It validates the address resolution protocol packets in a network. Very nice. So in your packet, if you remember, you got layer 3, the IP address, and layer 2, the MAC address information. And if someone is inserting a fictitious packet where those two don't match as like previous ones, it's going to drop it, and that's pretty cool too. DHCP binding database. DHCP binding database. Survey says yes. Okay. Will a switch drop or accept a DHCP release packet? Let's say. So, question is, will switch drop or accept a DHCP release? most likely, depending on where it comes from, it's gonna drop it. I don't like that. That question's not very good because it depends. Switch. It's a layer 3 protocol, but it operates on the switch at layer 2. Very cool. Alright. I don't think it does. Does not. Oh, it does. It does. It uses the DHCP binding database to create a list of binding address. So the correct answer is Y for yes. Very nice. The MAC address. Holy cow. We are done. Thanks for sticking with me for so long. I know 41 minutes and counting, that's a long time to watch. And hopefully these rooms get more interesting. I think from here, this is the last official one that I had to do for this course I'm taking. That's why I started this. So, but I'm gonna stay with this. I want to go through the red hat rooms and then the blue hat rooms as well, and see what type of fun. So hopefully this is the last video that's dry and monotonous. But thank you so much for watching. If you've really enjoyed it, give me a thumbs up, subscribe, hit the bell icon, ring that bell, and thank you. Yes! Yes! So what else? Did I get a badge? No. No badge.